low-income home buyers to kind of help lower their monthly payments. And we're looking at this with 3 speakers over the course of the next hour, and we're going to be covering some technologies and techniques to help increase the efficiency of these homes once they're renovated and possibly sold. So we're going to be covering geothermal, solar, and some leak sealing technologies. And I am going to go ahead and start with our first person who her name is Kylie Drucker. Unfortunately, she had a last minute thing come up, but she was kind enough to record a piece for us. And I will pull that up right now. Let's see here. Let's see. Here we go. All right, can everybody see that?
Yes.
Hi, my name is Kylie Drucker. I'm the owner and president of Delta Tempe, based in Dothan, Virginia, in the Central Virginia area. We specialize in geothermal heating and cooling systems as well as radiant systems. I am here today to talk to you a little bit about geothermal systems for residential homes and how they can be applied in your project. I'm going to first start with a little bit of brief history about geothermal. On my screen here so you can see. So geothermal systems, a lot of people think they're new technology. They've been used since ancient Egypt. There's history of it. But the first recorded geothermal system was in 1912 with a Swiss patent. Open loop geothermal systems have been used successfully since the 1930s. The Edison Electric Institute sponsored closed-loop research in the 1940s and 50s, but there was a lack of suitable piping materials that we use today that slowed the interest of the project. Swedish researchers began investigating geothermal closed-loop systems in the 1970s, and this is what the technology brought to the pipes that we use today in our installations. The International Ground Source Heat Pump Association was founded in 1987 at Oklahoma State University to study applications and establish engineering guidelines for the technology. And the Geothermal Heat Pump Consortium, a nonprofit group of geothermal equipment manufacturers, electric utilities, and contractors, was established in 1994 to help promote the use of the technology. So what is geothermal? What's the overall basic concept, and how can it be installed into a current residential home? A ground source heat pump system consists of water to air or water to water heat pump, connected to a series of long plastic pipes buried in the Earth's surface and placed in a pond. These systems can be utilized through well water placed in the earth loop, and as a fluid from the earth or well water is moved through the unit, the heat pump transfers that thermal energy. The Earth serves as a giant solar collector, storing that energy. The air temperature fluctuates as much as 50 degrees above and below the annual averages. However, only a few feet below the ground surface, the changes in the Earth's temperature are much less severe. So in our area, the Central Virginia area, for example, our ground temperature is probably about 55 degrees. It's a much more constant temperature to work from than the variables of outside air temperature. I'm going to show you a brief video. This will give you a great introduction to geothermal. This is provided by Water Furnace, who we're dealers for, but it'll just give you a general idea of the technology. Just a second.
Right, and bear with me just a moment while I pull up that video for you. Let's see.
An abundant source of free, renewable energy could be used to heat a house in the winter, cool it in the summer, and water all year round? Well, a growing number of homeowners say there is, and it's powered by the sun. While you may be picturing solar panels, these homeowners are actually talking about geothermal. If you're a typical homeowner, almost two-thirds of your total energy bill is for heating, cooling, and hot water. The rest is for lighting, appliances, and other usage. That means the biggest opportunity to save money on your energy bill is to increase the efficiency of your heating, cooling, and hot water system. A geothermal heat pump taps into the renewable solar energy stored in the ground to provide savings of up to 70% on utility bills. Although it operates similarly to a standard heat pump, a geothermal heat pump exchanges heat with the earth instead of the outdoor air. Outdoor air temperatures can vary greatly from day to night or from winter to summer, while the temperature just a few feet below the Earth's surface stays an average 55 degrees to 70 degrees Fahrenheit year-round. To see why that's so important, let's look at traditional conditioning systems. In order to cool your home, an ordinary system collects indoor heat and expels it outside. Unfortunately, summer temperatures can easily hit 90 or 100 degrees, which means outdoor air already is filled with heat and is less willing to accept more. The exchange process becomes harder and harder. The result is that an ordinary heat pump or air conditioner becomes least efficient at exactly the time you need it to be the most efficient. A geothermal unit never sees hot summer air. It collects heat from your home and moves it to the much cooler 55-degree Earth. It doesn't matter how much outdoor conditions fluctuate, the ground remains relatively constant. Thanks to the constant temperature of the Earth, a geothermal heat pump is more than twice as efficient and cooler than any regular heat pump or air conditioner. To warm your home, an ordinary heat pump reverses to collect outdoor heat from the air and move it indoors. Unfortunately, as winter temperatures drop, there's less and less available heat to collect. Again, the exchange process becomes harder, and the heat pump becomes least efficient at exactly the time you need it to be the most efficient. A geothermal unit never sees cold winter air. It draws from a reservoir of much warmer 55-degree temperatures, concentrates it, and moves it to your home. And unlike a traditional furnace, which returns less than 96 cents of heat for each dollar spent burning expensive, polluting fossil fuel, a geothermal heat pump returns up to $5 of heat for each dollar spent on electricity. That's because, unlike a furnace, a geothermal heat pump doesn't create heat through combustion. It simply collects and moves it. Now that you know the benefits of using it, let's look at how it's accomplished. A geothermal system uses a series of underground pipes called a loop. The earth loop eliminates the need for fossil fuel. It's the heart of a geothermal system and its biggest advantage over ordinary heating and cooling technologies. Closed loop systems circulate a water-based solution through a collection of small diameter, high-density polyethylene underground pipes. There are three main types of closed loop systems. Where space is limited, vertical loops are used. Well drilling equipment is used to bore small diameter holes, 100 to 400 feet deep. Horizontal loops are generally preferred where more space is available. Pipes are placed in trenches that range in length from 100 to 400 feet. If a nearby body of water is available, it can be utilized for a pond loop. Coils of pipe are simply placed on the bottom of a pond or lake to capture the geothermal energy. Open loop systems are an option if water is plentiful and low in minerals. These systems use groundwater from a well as a direct energy source. Water furnace dealers and loop installers are trained to design the best loop system for a particular home to ensure optimum performance. You've learned that a water furnace system lowers bills dramatically by using the stored solar energy in the ground. You've also learned how the system works. Now, let's look at its other benefits. Water furnace geothermal systems are recognized by the United States Environmental Protection Agency as the most environmentally friendly, cost-effective, and energy-efficient heating and cooling technology available. Geothermal heat pumps help electric utilities achieve significant reductions in their peak demand loads. By reducing the demand on electric utilities, geothermal systems reduce the need for new power plants, which typically are powered by coal or natural gas. Compared to an electric resistance heating system, a typical 2,500 square foot home with a geothermal system can save the electric utility company more than 9 tons of coal a year. These systems also minimize the threat of acid rain, air pollution, the greenhouse effect, and global warming, problems directly linked to the burning of fossil fuel. In fact, installing a single geothermal unit is the environmental equivalent of planting 750 trees or removing 2 cars from the road. As you can see, there are many reasons to switch to a water furnace geothermal heat pump. It's the most efficient conditioning system available. It's environmentally friendly. It has the longest lifespan, and it provides quiet comfort. That's why we call it smarter from the ground up. For additional information about the benefits of a geothermal heating and cooling system, visit waterfurnace.com or contact your local water furnace.
All right. All right, and I'll jump back to her presentation here, and I just needed to fast forward through it. But first, I just wanted to clarify Kylie's background. She's a 3rd generation HVAC contractor and the owner at Delta Temp. And Delta Temp here in the Richmond area, down in Midlothian, they specialize in the design, installation, and service of geothermal heat pump systems in the Central Virginia area. And they've worked with a variety of residential projects, including LEED Platinum and Earthcraft certified homes. And so I'll pull her back up to
All right, now that you've got some of the basics about geothermal, let's talk about how we apply it to the homes that you're working on and what it means for you and your homeowners on the installation side.
It's not sharing yet, Jeff.
Oh, okay. Sorry, just a second. All right.
All right, now that you've got some of the basics about geothermal, let's talk about how we apply it to the homes that you're working on and what it means for you and your homeowners on the installation side. I'm going to share my screen again and let you get information here. So you saw in the video, it talked about the different types of loop installations. So the process of installing the system, it is a heat pump. So you're going to have a component that's in the house, whether it's one component or two, and you're going to have a duct system, same as you would with a traditional system. The difference is you're going to have this loop field. There is a closed loop field, as you can see, and that's an example right here where it's horizontally trenched. In the Central Virginia area, we have a frost line of about 18 inches. So those pipes are about 2 feet to 5 feet in the ground typically, but it can vary from contractor to contractor how they install them. You'll also see here that there are vertical systems. This is typically installed when maybe you have a space constraint or you have an existing landscaping that you don't want to mess with. So these are available in the Central Virginia area. We typically have 2 types of drilling to put these systems in. There's rock drilling and then there's considered mud drilling. And they come at some different price points. We can talk about that later. This is a pond loop system where you would just, it works exactly the same way, but this set of coils would be within the pond, disseminating or absorbing or rejecting that temperature. And then another type that's installed is an open loop system where you take the water out of the well, take advantage of the temperature off that water basically, and then you would dump the water. These can be installed, typically we do not put them in new construction, a lot of times because of the mineral content of the soil around us. So we talked about, here's a little breakdown of the details of the installation of that system. So you're going to have the equipment sitting inside, maybe in the same space you would traditionally have a system inside, in a crawl space, in a garage, in an attic potentially, a basement. And so you'll have the system sitting there, and then the loop would connect to it through one supply and one return. So it's typically 2 pipes entering and coming in and out of the house at the foundation. And then they would come out to an exchange of pipes that would run out, loop out, and come back in. Here's an example of one that's been installed in the field. So you can see the pipes pinned up against the side here. And then this is all backfilled. So once the loop is filled back, you would know. There's typically some settling. Obviously, if you do disturb soil, you're gonna see that on a construction site. But once it's in there, the life expectancy of that loop field is over 100 years old, unless for some reason it is damaged. We put tracer wire in ours so that we can find them in case you need it down the road. This is examples of some equipment that we install. This one right here on the left side of the screen is considered a package unit. So a portion of it on the bottom is the compressor, and this upper section is the air handler. This is the only piece of equipment you would see. You wouldn't have anything outside. So this would be that unit sitting in the same space approximately that an air handler would. You see on the front of this unit, there's the pipes for the supply and return, entering and exiting. This system sitting next to it is a pair system. It's a split system. So this would be the compressor portion, and this would be the air handler portion. So a lot of times these are installed in a situation where we're not running water lines through the house. We might keep the compressor section on the lower floor and then put the air handler in the upper floor. A lot of times it also may depend on an existing home. If we're retrofitting a geothermal system for it, this type of system might work better. Now, of course, there's a line set between them, so that's how they're connected. This is an example of a package installation. You'll see here on the right side of the screen, there's a flow center that is moving that water through the loop field, pushing it through the unit, and then pushing it back out into the loop field. This is the supply and the return of that system from the loop field here. You can see this flat piping. And then, just like you would see with a traditional system, supply return ducts. This is an example of zoning controls. So we are advocates for reducing the equipment for a system. So we would produce zoning in the house through controls rather than additional equipment. So you heard a little bit about some of the benefits of geothermal systems. Let's talk about that. Obviously, the energy saving on the heating and cooling costs. Depending on what your homeowner has or they're moving to, these vary from home to home. There's some really great tools on our website and on the Water Furnace Dealer website where you can go in and type in the address and see what the anticipated savings would be annually if you were to switch to a geothermal system for that home. It's a great, really tool to use. And something here is the domestic hot water. So just like a car engine running, when this system's running, it's producing heat. Well, we take advantage of that heat by harnessing it to heat your domestic hot water. So it, again, reduces the cost of heating the hot water for the kilowatt that you've already spent to heat and cool with. They have quiet operation. They're all electric systems. It's quieter than a refrigerator running in your home. There's no outdoor unit, so it is not exposed to the elements. You would only have that heat exchanger loop in the field, in the ground, so you don't have anything to maintain outside. Again, that leads to less maintenance costs and repairs. Life expectancy. So geothermal systems have a life expectancy, according to the EPA, of 20 to 25 years. That is 2 to 3 times that of traditional air source systems. So what does that mean for the homeowner? It means that they're going to have that equipment for a longer period of time, so they don't have replacement costs reciprocal within the lifespan of that equipment. It's clean and safe, like I said, no combustibles. It's an all-electric system. It helps with electric demand for the electric companies, reducing that need for call in the peak times in the summer and the winter because it's constant. We're again using that constant ground temperature. Now, what are some hurdles? I call them hurdles because they're not things that can deter people from geothermal, but sometimes they can make it difficult. The first thing I want to talk about is understanding the technology and the level of trust. At the beginning, we talked about geothermal being a relatively new technology to the U.S. market. So sometimes we might encounter homeowners have a harder time kind of really trusting it because they haven't seen a geothermal system in function. They haven't seen it in a house. And so I think that really leans onto contractors and HVAC contractors to help provide an understanding of the technology, to help build that trust, and for them to understand that this is something that is supported by lots of industries and it is new to them, but it doesn't mean that it isn't going to work for their system. Space constraints. So sometimes you just have a property that does not allow space for the system. We like to say that if you have a lawnmower, you can have a geothermal system because vertical loop fields, or a borehole down. So as long as you can get a drill rig in there into the property to drill those loops, in most cases, you can have a geothermal system. There are some cases that we just can't because of access, typically. But kind of with the space and the budget, and these kind of things can go together. So in Central Virginia, we talked about a little bit about that vertical loop field. So if we're putting in the vertical loop field, it can drive those costs up for installation a little bit more than, for example, a horizontal loop field because of the drilling cost. So the space and the budget, they balance each other out. So that can be a hurdle of installation. A lot of people ask, what's the general upfront cost for geothermal? I like to say it's typically 2 to 3 times that of a traditional system. So assuming you're putting a traditional system at $10,000, you might be looking at $20,000. Of course, every house is different. Every need is different. And in comparison to picking accessories for a car, there is a wide variety of what you can choose to design for your home. But I'm going to do some simple math. I'm going to flip that around a little bit. So the upfront cost can be a hurdle, but I'm going to do some simple math to explain how it can be beneficial, especially for a homeowner maybe that's doing a mortgage situation. So they're adding, let's say, $50 a month to their mortgage, but on their general operating costs, they're saving $200 to $300. So they're saving $150, maybe more dollars a month just because they have a geothermal system. Plus, they're saving on the maintenance and the life expectancy of that system. So it's simple to show the math of why it makes sense to invest in geothermal systems. That's my basic overview of geothermal systems for Central Virginia. I would be happy to answer any questions that you may have. Again, here's my contact information I can share with you. My name is Kylie Drucker, again with Delta Temp. My email address is Kylie, Kylie, at deltatempinc.com. And the phone number of our office is 804-739-5854. Thanks so much. Thanks for letting me have the time to talk to you today, and I appreciate it. Have a great day.
Okay, everyone. So just to brief you on some things, geothermal is expensive, and we completely understand that. We just want to bring forward some ideas. They're not necessarily new. Geothermal's been around a long time, that might fit in 1 out of every 50 projects. With ARS, that is an allowable system. I can't speak for other programs, but if it were to work, and if it were to work in your budget, that is something that could really, as we said, this is so important to bring that cost down for the homeowner for the foreseeable future, and to be able to knock their bills down with us taking the brunt of the cost. So just something to think about as you go forward. And let me just pose a question real quick before we go to our next speaker. How many of you all have installed or have maybe in your own residence a geothermal unit that could just say something? Donald Goodwin.
I installed one when I built my house in 1986, 84, and it's been working great. The water temperature is so constant, which makes it just kind of trot along. It doesn't have to, when it gets 100 degrees outside, the heat pump is really fighting to get that cool air, which a lot of people complain about. And then in the wintertime, it doesn't get warm enough. You got 86 degree air coming out of a register. And if you're old like me, that might sit cold coming on your feet, 86 degree when your body temperature is 98.6. But yes, mine's been working great. It was a Florida unit, so it's been working great. I have replaced it once, and that was only about 5 years ago. So it lasted from 86 up to about 2000, whatever, about 5-6 years ago. I'm a fan of them.
All right.
You.
Thank you. And Mike Pageant, you had your hand up. Oh, you're muted.
I put them in 2 houses back in the 80s, but have long since moved from those houses. But yeah, they were great.
Okay, thank you guys. And like I said, it's not something that you're going to go and you get a geothermal and you get a geothermal. It's not going to work in every house. I completely understand that. But again, today is just a way of, submitting some new ideas and different ideas and things for you all to think about.
I also installed a tankless water heater when I built that house. I think it was probably there were only 2 companies that were making them or something back then. But that's another option that these rehab specialists could look at too.
Oh, absolutely.
Because it only comes on when you cut the hot water on. So you don't have
My
to
dad-
heat it all day long in a tank.
My dad has one and swears by it.
Yep.
All
you.
right. So any further questions on geothermal? We apologize she couldn't speak live. She just let Jeff and I know like at the last minute that she could not be here, but she had made that tape for us over the weekend. Any other questions before we move on to the next guest speaker?
Donald, I'd like to know what is an average bill and since you have that geothermal system.
Our utility bill from Dominion is normally about $120 some a month. It never gets. Well, we're on the plan that gives you an average, but before we even got on that plan, I mean, it never went over $200.
Okay.
So we're steadily at around 125, somewhere in that neighborhood.
That's decent. Thank you.
Okay.
And again, if any of you have any questions at all and you didn't happen to get her information there at the end, feel free to reach out to myself or Sherry, and we'll be happy to put you in contact with her and get some answers for you. And so that leads us to our next speaker, who is Louis O'Barry, and he's the Energy Services and Solutions Administrator for Rappahannock Electric Cooperative. Rappahannock Electric is a member-owned electric co-op providing service to over 170,000 connections in parts of 22 counties across Virginia. And whether they're connecting a renewable energy system, joining 500 plus member owners and a community solar, or considering purchasing even an electric vehicle, Rappahannock Electric they're committed to providing their member owners with sustainable energy solutions. And so to speak now, we have Louis O'Barry. You there, Louis?
I sure am. Good afternoon, everyone. I guess just to get a little housekeeping out the way, making sure everybody can hear me okay. If that's a yes, then we can certainly proceed. And I really appreciate the warm welcome, Jeff. And on behalf of REC, we thank you for inviting us to your workshop this week. I've looked at the agenda. It looks like you guys have had a great agenda packed full of really good information, all the way from energy efficiency and conservation down to now, kind of talking about other ways and other avenues to lower, reduce the barriers to access and to lower energy bills at the same time. So I recognize a couple familiar faces. I saw a couple people that I have engaged with in the past at DHCD, and it's good to see you all today again. And I hope you find this information somewhat useful. So without further ado, Jeff, if you don't mind teeing up that PowerPoint and put it in presentation mode. If you could run it in presentation mode, that would be ideal. It'll just make it a little bit easier for everybody to see. Now, if you're fighting 2 screens, that could be.
Yeah, I'm just getting it flipped around right now. So.
Okay. There we go.
Let's go to. How's that looking?
It looks exactly the same, but we can leave it in that mode if everybody's okay with it and can see it.
Oh, it should be flipping over. Let me. Get that switch back.
It's just a short slide deck. I'm actually going to speak more not necessarily directly to the slides, but it's more of a visual just as we kind of move through a little bit of information. So,
Okay. Well, technology's fine. I'll get that pulled up for you right now.
okay. You want to just run it there, Jeff? I'm good with that.
There we go. Did that fix it?
No, it still looks the same, but I say I say if everybody can see that okay and puts a thumbs up, I say we go ahead with the program. It's not a big deal. So
Okay.
thanks for having me today. And you go ahead and move to the next slide, Jeff.
Is that flipping over?
Uh-oh.
I'll tell you what I'm going to do. For whatever reason, it's not showing up.
There it goes. There it goes. It moved over. So just a few quick facts. Jeff covered a few of them. Just a little bit about REC for those of you that may not be familiar with us. We are a distribution electric cooperative. We serve 22 counties. We have about 4,000 square miles of territory within those 22 counties. We service a little over 171,000 meters or services in total. That includes residential, commercial, and C&I as well, or large power. We have 17,500 miles of power lines that we maintain, and right-of-ways. We have roughly about 10 accounts per square mile, or 10 meters per square mile. So we have a wide range of diversity in our territory. Obviously, a lot of electric cooperatives have 5 to 6 meters per square mile. So that kind of paints a picture that we do have some fairly dense areas in some of the suburban areas outside of other jurisdictions and places like that. So we generate about $416 million in revenue on an annual basis. We have 430 employees approximately, and growing here and there. And I threw this little tidbit in there just to kind of, since we're going to kind of gear this a little bit around renewable energy. To date, we have a little over 1,650 net metering accounts, and that includes both residential, commercial, and a couple large power scale or distribution level type systems. So next slide.
Okay. There we go.
So I think we can all agree that renewable energy resources are definitely a great thing to tap into. They can augment any project that you're working on. They can help reduce energy cost or monthly bill cost on the utility side. But really and truly, we know the foundation for a good foundation for a lower energy bill is obviously initially, with energy efficiency and energy conservation. And we know that when we renovate these homes and we do the appropriate measures, that's where we see our largest return initially. So we have to have an efficient house before we can couple it up with some renewable energy in order to have the biggest bang for the dollar. So, right now REC doesn't necessarily have what we consider a low income solar program or low to moderate income or LIHEAP program that would kind of be equivalent to some of the things that Dominion is doing now with a pilot that they're running. But we do have a couple net metering. We do have a couple solar options out there that could be considered within our territory. So we have a cooperative sun share program. Just to kind of, I'm not going to spend a lot of time on this because it doesn't necessarily always quite apply to what we're talking about here. But we do have access to about 9 megawatts of solar generation from 2 specific sites, one in Winchester and one on the Eastern Shore of Virginia. And the one on the Eastern Shore is Cherrydale. And please do not quote me because the name has changed on the one in Winchester a couple times since it was acquired by Dominion shortly after it got built. But we are a member of another cooperative, obviously, Old Dominion Electric Cooperative, which is where we purchase a majority of our generation from, and that's basically our piece of the pie of that portion of that renewable generation that's on the grid. So, out of that 9 megawatts of solar, we have blocks, if you will, that a member can prescribe to. They can look at their usage per month or per year on an annum basis and say, okay, I want to purchase 4 blocks of solar energy per month. Now, Don't let me paint a picture that we're separating those electrons in the grid, because we can't quite do that. I figured I'd throw that comic relief in there, but we are, this is a way for some of our members that may necessarily have some barriers to access for doing their own PV system on site, or just want to contribute and help go green. Now, these blocks of solar energy will cost a little tiny bit more on average as it compares to a typical kilowatt hour. And I just kind of put a reference there that if you did 4 blocks per month out of a rolling calendar year, it'd be about about $75, $76 annual added to the total bill. So not necessarily something that would paint into the picture here, but I didn't want to leave it out of the mix, since that is something that we do offer at REC. And then next slide. So net metering in residential and commercial. So this, as we know, this has gained a lot of traction with most any utility in the state. Back 5 or 6 years ago when I came, well over 6 years ago when I came to work for REC, we only had about 350 or close to 400 net metering accounts in totality. So now having almost 1,700 in the last couple of years, we've had a huge increase in traction with regard to residential and commercial members installing solar. So just to give you a little bit of background on that, we have a net metering program where we facilitate and assist our members in installing PV systems on their property. We limit residential systems to 20 kW. That doesn't mean everybody can have a 20 kW system. It's obviously based on your annual usage, and per the state code on net metering, it cannot exceed more than 100% of any particular member's annual consumption. So on the back end, we do the approval and denial of these systems, and we just and that's how we operate that program. We don't have an aggregated net metering. We used to do that back in the day, but now we pretty much offer net metering where one particular solar project can only serve one particular meter. So you can have multiple systems on your property, but they cannot be aggregated, if you will. They have to be tied to one specific meter. So we one PV system for any meter on the property. Now those rules are a little bit different when we move into large power and commercial, with the limitations on kW being quite a bit different on the AC output side. And but this conversation will be driven and focused more around residential accounts and things of the like. So next slide.
Lewis, before you go on, can you just give us a quick definition of what net metering is?
Okay, so net metering, for those of you that may not understand that fully, that is a program where if a member has, and you have PV installed at your property, we put a special meter there, and that special meter is designed to go both forward and reverse rotation. So anytime your home is using the energy that the system is producing at any given point of the day, we cannot measure what your system is producing. We can only tell you what you've given back to the grid and what you've taken from the grid. However, net metering is a way for our members to essentially go green and reduce their monthly bill, and offsetting that with renewable production from their PV system or their solar system. So that's how that works. So the meter has basically 3 registers in it. Those 3 registers will register both forward, reverse, and net, a net total reading. So the forward and reverse registers always go up, because that tells us how much energy you took from the grid in kilowatt hours, how much energy you place back on the grid in kilowatt hours, and the net is exactly just that. It's the difference between those two readings. So it just depends on how large your system is, how it was designed as it relates to your to your annual consumption, as to how much net you will have. Some members will net out at the end of the month. Some members won't necessarily do that just due to the size of their system. Also, there's other things that may not be quite in everybody's control, like behavior changes with the home, mechanical failures, or changes that would drastically affect how the system was designed to operate, or how the home is performing at that or how much load is on the home at that particular moment in time. So just a little background on net metering. That's what that means. And we have a couple of different options where you can have banked kWh that roll on not on a calendar basis, they just roll over month to month, so that we know PV systems generally peak out in production in the summer months, and they don't have nearly as much production in those winter months. So for members that have the banked kWh, they have a system where it may produce more than what they're using on a monthly basis in the summer months, that will roll into what we call banked KWH, and then they're able to pull off of that bank on that next month's bill. So if they have, when they're getting into the winter months where heating systems are driving that energy use up, if they have enough bank KWH, they can help offset those bills in the winter months. So that's why it's so important, if you have done the energy conservation measures and the energy efficiency measures in the home, and you've got the house within reasonably, a reasonable position where it's as energy efficient as possible or within reason, coupling it and adding some solar to the mix will reduce that bill from the utility even more. Now, obviously, there's an upfront cost for that. Solar has come down quite a bit in the last couple of years. It's down to about, really just depending on where you are geographically, anywhere from $3 to $5 a watt installed. But the barriers to access are less, and there are solar companies out there that do a good job at installing those systems. So next slide.
And we have one question from Kenny Rogers.
Sure.
Yeah, I just want to know, make it simple for some of us contractors out there. After you add this solar, is it an option that you could have a zero electric bill for 1 month or anything like that?
You could have no energy bill other than just the access charges and the taxes, which would be, right now on the residential side in our territory, it's $14 a month plus taxes. So if you had no KWH consumption for 1 month because your PV system was able to net out all the way, or basically you didn't have a need to use any energy from the grid, or if you did take some energy from the grid during that particular bill cycle, the amount of excess generation you placed back onto the grid for that particular bill cycle exceeded the amount of usage that you did take from the grid. So that's kind of how that net metering works. It's kind of like a push-pull, if you will. And for members that have systems that are large enough to offset their usage, especially in those peak production months, we do have members that have no power, no energy bill for certain months out of the year. It's unlikely in many cases, especially if you look at an all-electric home. If you look at mixed fuels, it could be a little bit different. But the all-electric home with average usage, you're probably going to have a few months out of the year where you will still have some KWH consumption because of the PV system is just not quite able to offset all of it in that particular cycle because of the time of year.
And just one other quick question: is it possible to bank any of this savings?
Yes, we do have that banked KWH option, which is what most members will do. So that banked KWH, let's say that you had. Let's say you had a month where you netted out and you had 50 kilowatt hours to the good, if you will, that month. So instead of you won't get money back in your pocket, you'll actually get what they go into a banked KWH credit that you accrue and you roll over. So that 50 kilowatt hour bank would be applied to the following month. So if you net it out again the next month, another 50 or 80 or 100 kilowatt hours, that too would go to that bank. So that bank is kind of it's there for the member and at the account level, so that if they have had excessive or enough excess production, they can pull from that bank. And if they didn't have it, let's say they were rolling into a winter month and we went from September, October, we had a base load month, we're in that shoulder period. We move into November, they start heating a little bit. The system didn't produce quite as much as they had used. They will use up that bank before we bill any additional KWH. So that bank is there just for that reason. There is another option with a PPA or a power purchase agreement, but I don't want to get too far in the weeds with that. And that's basically where there's a specified net metering period, and basically the member gets paid a portion of the KWH generation cost, which is roughly right now a little over 3 cents a kilowatt hour. So it's much better to take the KWH bank than it would be to get the much smaller payout of a PPA. So our role in net metering, I kind of hit on this a little bit. We assist the member in approving and denying the applications and the processes that are involved there. So we're dealing directly with the solar vendors. We field questions on the front end with the member. We have a great FAQ and kind of what should I expect on our website when we have members that are that are inquiring about solar. We have experts on staff to answer specific and pointed questions when installing solar. Our meter techs and our field staff inspect the systems and the interconnection itself, set the net meter, do the meter exchanges as it needs to be, and of course our billing department assist with updating the REC account to net metering and things like that. As of today, we don't install solar. We don't do any turnkey installations. We don't finance solar, so we're not a we don't carry that. We don't have the ability to do that as of now. We can't obviously monitor performance on a PV system. That has to be done at the user level with their applications and such that are associated with the system and the information that they get from their inverters. So that's what we do as of now, but that doesn't mean it's not going to change. We're definitely exploring ways to secure some grants and some different funding sources to help incentivize or to help reduce the barriers to access for all of our members, not just low income. We're also looking at some potential solarized campaigns to where we can kind of be, our members turn to us as the energy expert, and we want to be able to provide those solutions to them. Even if we're not providing a turnkey product, we can definitely guide them in making the right choices when it comes to installing a solar array at their home. So you would be surprised how many members, engage with a vendor and they truly don't understand the process, or they don't quite understand what they're purchasing, and the expectation level may be here, but the actual production and what the system was actually going to do may be down here. Education is key, and the more communication that we can have with our member, the more communication that we can have with the contractor and the vendor, is a win-win for the end user at the end of the day. And it doesn't matter whether it's one of our members or somebody on someone else's system. So we just want to be there and be that unbiased expert in that fashion. Next slide. So we do, like I said, we talk, talking about the basics, how we recommend solar to our members. We recommend getting 3 quotes like you would with any kind of major purchase, whether it be HVAC, whether it be weatherization upgrades, anything like that. It's always good to get at least a couple different quotes, especially in the private sector. This doesn't always apply for prescriptive utility programs or weatherization assistance program or things like that, which are much more prescriptive. We ask them to, go online, do some research on the contractor that you're getting ready to do business with. That's just kind of good measure, due diligence, if you will. We have a lot of new tools available to our members to kind of dive down into solar, find out if it pencils out for you, which is called Watt Plan. And I've got a couple slides in my appendix if you want to look at what that would look like for that platform, and you can go to the next slide on that as well. That's kind of where that is. And if anybody wants to kind of jot down that link, feel free to do so. I'm sure I can make that available in the chat and make that live. If you go in presentation mode, we could actually go into a live version of that, but it's quite all right. We don't have to go there today. But we did just implement this tool called Watt Plan, which is a really interactive tool for our members to kind of plug in real demographics about their home. It uses information, if any of you are familiar with the NREL website, which is PV Watts, which is a very credible resource for sizing and estimating what solar production could and would be at your specific coordinates. It uses a lot of information in order to gather that, but this is just kind of a quick overview, if you will, of that platform. And if you want to skip past slide 8 and go down in there, we could dive into that a little bit and let you see what that looks like. So feel free to go to our website and actually dive into that link if you want to, and just kind of play with that a little bit on your own home. And that's what it would essentially look like. There's a bunch of fields in there that you fill out about your exact coordinates of the home, and demographics there. And then as you move through those slides, you can actually even see how it breaks out the estimates on what it would potentially cost and sizing and things of that nature. So it's a really great interactive tool to kind of use as a backstop that the member can look at and compare this to their actual estimates that they're getting from solar vendors. So, how does this really tie into what we're talking about today? And upfitting solar to low and moderate income homes. I think it's like I said, this is ever evolving, and access to renewable energy is something that's going to continue to gain traction and continue to be in the forefront of kind of tying in that home run, if you will, from retrofitting homes and making them as energy efficient as possible, and coupling that with some renewable energy and potentially even a little bit of battery storage for some resiliency for those folks. So not only do they have a reduced energy bill because of the energy efficiency upgrades, we're taking it a step further. We're reducing it that much easier. There's programs out there to secure funding to help with solar installations. The bill is that much lower, and if you can couple that with a little bit of battery storage, you have the resiliency and the ability to for that member to be to maintain and not worry about a high energy bill in total. So I'll be glad to field any questions that you may have about our programs or about solar or PV in general. I'll do the best I can. Like I said, I'm sure I had some really tough acts to follow. And like I said, we really appreciate the opportunity to come talk to you today. I would say that since I've got the floor, before we move to questions, that I just will put a small plug in. I don't know many of you that follow what's going on at Rappahannock Electric, but you can go to our website. We are in the process of standing up an on-bill tariff program, which is an energy efficiency program that allows members to essentially, I don't like to use the F word on that, but essentially finance upgrades over a period of time. We are going to be the first cooperative in the state of Virginia since the legislation has passed to kind of open a door for on-bill tariff type programs. We have a lot of work left to do. We are trying to stand this program up in some form. We're not sure exactly what it's going to look like in phase one, but we're looking to stand this program up in Q3 of this year. So we're hoping in June of 2022 we can do that. And we are certainly we're at the point now where we've got board approval. We are seeking the RESP loan to acquire the backing to support this program. We think this is a great member-facing, an excellent program for all the ratepayers and members on the system. As any kind of demand side savings there. But this is a great way for members, and not just. We realize this program will parallel and maybe overlap a little bit with some other low-income programs, but we're also going to kind of identify and navigate the member where they best be served, where they're best served. So this is open to all income brackets, and it's going to help. We're going to pay up front, heat pump upgrades, insulation, air sealing, and things of the like. So it'll be a prescriptive type program based on a 10-year payback. And it's and the tariff. What's unique about this is that the tariff is applied as a rate to the residents, and it stays with the meter. So it can be used for owner-occupied residences. It can be used for rental properties, and it's not just limited to all electric homes. It's going to be a mixed fuel. So there's still some developmental things that probably need to happen at the state level to kind of define energy savings a little bit more broad, and we could probably expand this program to other DERs and even potentially solar and things like that. But right now the program is kind of narrowed down and honed to specify that there has to be deemed electrical savings. So when we can open that up a little bit more, that will definitely, we feel on-bill tariff is just the first step in reducing the barrier to access to energy efficiency upgrades. But we also think that on-bill tariff will be a key that will unlock a door in the future for other things, such as renewable energy storage and other DERs. So I hope this has been somewhat helpful. Please go to our website. Please, if you're a contractor here today and you're in the HVAC field or you're in the weatherization sector, insulation and air sealing, and you have some expertise with that, we are looking for you. I hate to put that plug in there, but we are certainly looking for experienced and qualified contractors for the program. So feel free to go to our website, ask some questions about on-bill tariff, and if you have some interest in getting some more information to be a provider in the future, we'd love to hear from you. So thank you very much. I'll be glad to field some questions.
Perfect, Lewis. Thank you so much. It looks like we might have time for one quick question, and any others that come along throughout this, feel free to reach out to Lewis directly or Sherry or myself. But Janet Jonas asked, she's interested in how we could braid this technology in with historic tax credit projects.
That's interesting. Well, we know that the federal tax credit on solar is set to expire in 2023. I think that I think it's safe to say that there's a chance that it could be extended. I think they're just going to carry it forward for battery storage, and essentially the solar tax credit is slated to kind of go away, if you will, after 2022. It'll be interesting to see. It just all kind of depends on at the legislative level and what kind of influence is there, as whether that will extend or not. But I think that that is one way to kind of braid, energy efficiency measures in the house, braid together incentives for installing renewable energy resources at the house. And solar is typically at the top of the list because wind is much more expensive to install. It's a lot more expensive to harness that energy. So when we think renewable energy at the residential level, we are certainly thinking solar. So that's a good thought. And the metrics on how that would look, how we braid that together, I'm not sure I can answer that but at a high level, I think that's certainly something that we should definitely consider is how do we braid programs together? How do we blend funding together? We've got all these programs out there. We've got, all this money coming into the system with the Reggie dollar, the grant money from the high E funds on the rehab. And, we've got access to a lot of different ways to reduce those upfront costs for that income class. I mean, that's something we definitely need to look at closely.
Perfect. Well, yeah, thank you again. And I hope that clarified it a little bit for you, Janet. And again, thank you, Lewis, for taking the time to speak with us today. And again, if for anybody that wants it, we'll be happy to pass out his information, and you can contact him directly or reach out to us. And so for our next and final speaker, we have Troy Wilbanks. He is sales manager at Aeroseal with a particular focus on our national builders. His work specializes in helping residential and commercial architects, builders, and developers create more cost-effective, energy efficient, and healthy builds. Aeroseal is a climate tech company using its leak sealing technologies to reduce the world's carbon emissions by 1 gigaton annually, with a presence in 27 countries and all 50 states across the US. Their network of dealers have sealed nearly 200,000 projects and saved nearly $2 billion in wasted energy. And so if Troy is here, I'll be happy to pass the floor over to you.
Perfect. Thank you very much. And, thanks for inviting me. Appreciate everybody taking the time to attend today. I'm going to present my screen now. And can you see my presentation?
Yes, we can.
Okay, perfect. Yeah, so once again, thank you very much for taking the time to attend. As Jeff said, my name's Troy Wilbanks, National Sales Manager for Aerobarrier. Very excited to be here. I think there's a lot of areas where our technology could help, align with a lot of the goals that everybody really has in the affordable housing, world, with a little emphasis on rehabs as well. Really, helping, reduce energy bills and provide a more comfortable environment for the occupants and reduce bills for the owners as well. So really, basically what we're going to cover today, a little bit about the company, then we'll touch on the benefits of air sealing. I think that's important to really grasp at the beginning. And then we'll touch on our two technologies, Aerobarrier and Aeroseal, go over a quick case study, and then open it up to Q&A. So history of the company is pretty simple and straightforward. We were started in the early 90s. Aeroseal was. And Aeroseal is a technology that focuses on sealing ductwork from the inside out. Took off very well, as you guys can see, won quite a bit of awards. And as sustainability and really just energy conservation became more and more higher of a demand, and codes became stricter and stricter, blower door tests started being enforced. More duct blaster tests were being enforced. Our builders came to us and said, "Hey, we love what you did with ductwork. What can you do with the building envelope?" So in 2016, Aerobarrier was born. That's the 19, and are on having a major impact in really the built community, whether we're talking about single family detached, multifamily affordable housing, or commercial. So the benefits of reduced air leakage we focus on a lot, as you can imagine, because we are an air sealing company. Number one really topic that people talk about, and it's where their minds typically drift when they think of air sealing, is reduction in heating and cooling bills. Reducing that monthly bill, that annual bill, not only for the tenant but for the owner, if the owner is responsible for paying certain portions or all of certain bills. This matters across the board, but when we're talking about affordable housing, it really does get magnified. If we can save tenants, $10, $20, $50, $100 a month, that could be, that could have a substantial impact on their life. Also not listed here, but it's going to be very important for all the GCs out there. Benefits of reducing air leakage is going to be passing blower door test. I know Virginia, is going to start enforcing 5 air changes per hour with a blower door test. So it's extremely important to be able to pass those, get your COs, and then on with the additional benefits of reducing air leakage and proper air sealing is what I like to call the butterfly effects, and they really matter. They're going to provide the occupants with just a much better place to live. Less change in temperature, fewer drafts. Proper air sealing will actually reduce or diminish noise transfer from unit to unit up to 40%. Also, you can imagine if all the leak points are sealed up and there's no areas for odors to transfer through or pests to transfer through, it's really going to have a major impact on reducing that, ultimately providing a better life for individuals and reducing complaints as well. Before I get into the technology, I like to take a second to kind of paint the picture of how they work, right? And really, both Aerobarrier and Aeroseal rely on physics. And the best analogy we can come up with, and everybody's probably familiar with, is a balloon, right? So, you have, the balloon is pressurized, and if there is a hole put in it, imagine putting a little pin in a hole, all the air is going to rush to that hole. That's the leak point. That's the same working principle that both Aerobarrier and Aeroseal technology operates on. Positive pressure on the inside of ductwork or a home, unit, condo, apartment, warehouse, whatever that may be. We're going to put positive pressure in. It's going to force air out to the leak points and carry sealant with it and seal it up in the process. So just kind of a high level overview kind of framework of it, of how it works. And now we'll hop in to Aerobarrier itself. Essentially, Aerobarrier is an automated air sealing technology that guarantees that you meet whatever air sealing requirement you're looking for. Whether it's 3 air changes, 5 air changes, 0.2 air changes, we guarantee that you meet that, and it eliminates the need to manually air seal. So going to take a lot of management aspects of a project as far as managing who's doing the air sealing out. It can also provide a lot of really opportunities, financial opportunities, when we're talking about how we can size mechanicals. So if your goal is 5 air changes per hour, if you're just trying to meet the code requirements, but we can guarantee that you come in at 2 air changes, all of a sudden you're taking, half a ton to a ton off of the mechanicals, and being able to put that money back into the project to provide a better build, all in all. So hop into the process itself. It's very simple. It's 3 steps. The first thing we do is prep the unit. So we come in and we tape off any of the designed openings. That's windows, doors, fireplaces, things of that nature. Then we take a modified blower door and put positive pressure into the space and pressurize it to about 75 Pascal. Once it's pressurized, we do essentially a blower door test. So we get currently how tight or how leaky that space is. So that's our baseline. And we have a predefined goal, whether it's code, whether we're looking for passive house with 0.6, whatever it is. Once we do the baseline test, we know where we're at and where we need to go, which is perfect. So at that point, we start to atomize the sealant into essentially a fog, and then physics takes over. Positive pressure is going into the space, and air becomes our mode of transport. air is traveling out of the unit through those leak points, and it carries our sealant with it and seals it up in real time. The entire process is completely regulated. So, we have complete control over how tight we want the unit to get. This is great for a couple reasons. One, you'll pass every blower door test, and that's guaranteed up front. But two, you'll never leave a unit too leaky or too tight. Really what that means is you guarantee that the air tightness is going to align with what the mechanicals were specified for. At the end, you get an envelope sealing report. This shows, exactly what happened during the seal. Data is provided in the before service and after service categories there in 3 different data sets. CFM, what everything would look like, it would add it up to a 1 square inch hole, and then air changes per hour, which is the kind of the language we speak when we're talking about residential air sealing. So in this example, it was a townhouse, took it from 34, almost 3,500 CFM of leakage down to 356. If you added up all those leak points before the service, they would add up to about 418 square inch hole. After service, it was it was 42 square inches. Air changes per hour taken from 8.57 to 0.88. We did that in about an hour and a half. So don't know a trade or a technology out there, that can really do that. And another benefit to this envelope sealing report is, in most municipalities that we work in, and I can work with the code officials on this as well, this can be used as proof of compliance for a blower door test. As a builder, as a GC, anybody that's interested in these projects, that you passed your blower door test and you have proof of compliance at drywall and first coat of mud. You don't have to cross your fingers at finish. Some really good pictures of what a seal looks like. But it does bring up some questions, before and after the seal, what happens when they move the wires around? You can see the middle picture. There's a little kind of build up, what is the rest of the trades going to do when they come in? So really our sealant has a plus or minus 20% flex rating. So the electrician could come in and move those wires around, not going to depreciate the integrity of the seal. And it's 100% sandable and paintable. So the drywall crew and paint crew can come back and do everything just like they normally would, right? Then I really like that bottom picture right there. It just shows the power of physics. There's 3 leak points. Physics identified it, carried our sealant with it, and sealed it up. Typically, if that was manual air sealing, we would see no sealing done, or every seam would have foam or caulk or something in it, which is just added labor hours and added material costs. So we can back all that out. So high level, that is Aero Barrier. Once again, it guarantees that you pass every blower door test and guarantees that you meet whatever air sealing requirement you're looking for, which has huge implications if you're looking to capitalize on the low income housing tax credit, if you're trying to meet Energy Star, net zero, or pass municipal code. So especially on rehabs, it's difficult to get back in a wall system and properly air seal for something that was built 10, 15, 20 years ago. So now we're going to transition over to Aeroseal, which focuses on the ductwork, which is a fantastic tool to help meet the requirements for any duct blast testing that you have to achieve. So works on the same working principle. Once again, physics, pressurization, atomization, and airflow. So really, it's a similar 3-step process, and all in all, it can reduce 90% of duct leakage. It works the same way, finds and seals undetectable and unreachable leaks through physics, can seal to 5/8 of an inch hole. Right? As I said, pretty much the same concept, except we're talking about ductwork instead of a whole building. So the first thing that our crews do is set up. So they block the registers, furnaces, and really put our injection points in the ductwork. Atomize that sealant. It's pressurized. That sealant is going to go through and find those leak points and seal them up from the inside out. So no more ripping out drywall. No more wondering if you're going to pass a duct blaster test. And also can't forget really just increasing the efficiency of the spec equipment or existing equipment if you're going to keep the existing equipment for a rehab. Then you get your certificate right there, and that can also, depending on the municipality, be used for proof of compliance for a duct blaster test. So going to touch on this real quick. It's a great project that we did, and it really just shows the full impact that proper air sealing and aero barrier can have when we partner with our clients in the built community. So the Wasatch Group out in Utah, there's really not that much code enforced in Utah. In Salt Lake City, it's 3 air changes, but everywhere else, there's really not code. So the Wasatch Group, they were building a 600 unit development, and they were averaging about changes per hour. So we came in and said, okay, let's do some value engineering exercises and take a look at the impact it would have if we guaranteed you at 1 air change. Overall, it cut energy consumption by 50%, and drove rebates and financial incentives that really was about 150% ROI on the project as a whole. One thing that I really like to point out is the impact on the mechanicals. So, through energy modeling, their 3-bedroom units needed a 3.5 ton gas furnace. That's what was required. Once we guaranteed them one and did a value engineering exercise, all of a sudden it turned that 3.5 ton gas furnace into a 1.5 ton VRF electric system. It enabled them to shrink the size of the ductwork and the vents, change out their insulation package, and qualify for a lot of financial incentives. The 45L tax incentive, I would recommend to everybody to look that up. We anticipate it being renewed this year, but you can capitalize on $2,500 per unit for a tax credit. And air sealing was a major component of that. So big picture, what we're looking at is just through air sealing, just through implementing aero barrier, they reduce their capital expenditure drastically up front. By downsizing this equipment as well, they're going to reduce the carbon footprint and the energy consumption of each unit and the development as a whole, and really just provide all the occupants with a more comfortable environment, right? Fewer drafts, more consistent temperature, no noise transfer, smell transfer, pest transfer, really just eliminating that, out of the gate for them. So I know we covered a lot, so I wanted to put this slide up. Really the positive impacts we're having with our partners, there's a lot. The main ones though, better built, reducing energy consumption and providing cost savings for the occupants as well as the building owners. Code compliance, guaranteeing that you pass every blower door test and every duct blaster test, whether that's 5 air changes, 3 air changes, 0.6, really doesn't matter what it is. We just have to run the equipment for a little bit longer. Reduction in cost of the build, if it's a total rehab, right? Taking a look at saying, instead of going for the 5 air change requirement, what does it look like if we come in at 2 air change? Can we take a 0.5 ton to a ton off? We definitely can. And then financial incentives. There are so many out there, financial incentives that air sealing ends up being a part of, whether it's your QAPs for your low income housing tax credit, whether it's certification of net zero or Energy Star or LEED or Passive House, whatever it may be. There's a lot of tax or financial incentives out there that proper air sealing can help with, and Aero barrier and Aeroseal are the great technologies that can help do that. So, all right.
Thank you, Troy. It looks like we have maybe a minute or so left, so might only get one. But if anybody has a question, feel free to chime in or type it in the chat real quick.
Sure.
Hi, this is Kenny Rogers. I got a quick question.
Yeah.
We're building 1,000 square foot houses. Can you give us an idea your cost to do your ceiling for a 1,000 square foot house?
Yeah. As you can imagine, it varies. So I'm with Corporate. We have our network of partners, so we don't control the cost.
Okay.
That being said, what we're seeing for 1,000 square foot single family detached house, $1.10 to $1.20 a square foot of conditioned space. Once we take a look at what we can back out as far as air sealing and everything else, though, typically what we're seeing is for the project, it's cost saving or cost neutral, with the guarantee of the blower door test being passed and all the other benefits that we talked about. As far as multifamily, that can range from 90 cents to $1.15, $1.20
Okay.
a square foot. And really, as just like with every other, with every other thing out there, the more volume you have, the better price you're going to get. It's the same thing if I buy chips or buy shingles. It's just the kind of way that it works. So,
And can your system also be done? I know you talked about it, but for an existing home, how does that work with an existing home?
yeah, that's a very good question. So, it can be done for an existing home. It cannot be occupied. Well, it could be. Existing homes, it just takes a lot more prep work. So the sealant, when it falls out of suspension, will land on horizontal surfaces. So floors, countertops, things of that nature. And it will have kind of a sticky residue. It dries, but and it can be cleaned up. But the best thing is to not let it happen.
Okay.
So in a finished house, or if you're doing a moderate rehab that has some finishes in it, all we have to do is cover those spaces. Yeah, and honestly, we do quite a bit of rescue work. That's what we call it, which is it's not fun for everybody. But I had one. A gentleman had 12 apartments in DC that were failing their blower door test, so he couldn't get their certificate of occupancy. So we came in; they were completely the finished stage, and we sealed those. But we're involved in all of his projects now after that amount of pain was felt. So
Great, thank you.
Perfect.
You are
Thank
more than
you.
welcome.
Okay. It's and I think we'll go ahead and wrap up here. Just real quick, Troy, would you be able to, for people in specific areas, would there be a spot that you'd recommend that they check out their local dealers or who
Yeah.
to get in contact with?
You can check out our website on our dealer locator. But honestly, this is what I do. I work directly with architects, builders, general contractors, trades, and then introduce them to our dealer network. So if you have any interest or a project you're thinking about, or just have some more questions, give me a call. Shoot me an email. We can set something up.
Perfect. Thank you so much, Troy.
You are more than welcome.
It's that was very informative, and I will go ahead and pass it on back to Sherry.
Perfect.